Notebooks. Before we get into some of our proofs today, we're going to talk about some of these properties. And most of these properties are properties that you have seen before, okay? Maybe not for a while. Like when you first started solving equations way back when, probably in Algebra 1, maybe a little bit before Algebra 1, then we talked about these properties because these are the properties that tell us what we can do to solve an equation, okay? And what you're going to notice here is that we have our four operations that are all basically doing the same thing. The substitution property is going to be a little bit different. We've used it before, and then distributive property is one that we've seen a lot before, and talked about that. And so most of these things, what you're going to see or what you're going to recognize is that we've done a lot of this stuff before, but we haven't necessarily done the part where we're going to state what's happening. Okay, and this is going to be kind of a intro into doing other types of proofs that we're going to see later on in the chapter. Algebraic proofs are just trying to identify what's happening in the equation. Okay, and so when we do these, we're going to have to identify, and it's going to be a little bit longer process than what we're used to when we typically solve an equation. Okay, all right. So the addition property of equality says if A and B are equal to each other, then as long as I add the same thing to both sides, the two sides are still equal. So here would be an example. If x equals 3, then x plus 2 equals 3 plus 2. Those two sides of the equation are still going to be equal because all we did was add 2 to both of them. If I want to put a number in there, if I want to say if 4 equals 4, then 4 plus 3 equals 4 plus 3. Okay? Right now, does 4 equal 4? Is that a true statement? Yeah. And as long as I add 3 to both sides, still equal, right? Both sides would still equal 7. So what we've talked about with equations for forever is whatever I do to one side, I always got to make sure I do it to the other, okay? I can't just add 3 over here to the left without doing it to the right, okay? And that's what all of these properties are essentially going to be saying. When I talk about addition, subtraction, multiplication, division, the same rule is going to be true. The only difference is what operation am I using, right? We're going to do add, subtract, multiply, and divide. So the second one says subtraction property of equality. If A and B are equal to each other, then A minus C equals B minus C. Okay, so if I said something like if 5 equals 5, then 5 minus 2 equals 5 minus 2. And it doesn't have to be a number. It could be a number, it could be a variable, it could be anything, right? And so whatever we're looking at there, as long as they're equal here, and I do the same thing to both sides, they'll remain equal. So here all we did was subtract 2 from both sides, and 3 is still equal to 3, so these two sides are still equal to one another, okay? And so this time, same thing, except we did subtraction instead of addition. Okay, multiplication, not going to be any different. If A equals B, then A times C equals B times C. So if I said if A equals B, then four times A equals 4 times B. Typically with multiplication, we won't put an operation in there. One thing that you're going to have to start getting away from, if you haven't already, is we can't use the x for multiplication anymore. Okay? Once we're in algebra and we do things with algebra, this gets to be confusing because when I see x, what am I thinking? I think, yeah, a variable, right? It's going to represent some value. And so then when you look at a problem, if I write x in there, am I talking about multiplication or am I talking about a variable? That's why we don't want to use x for multiplication anymore. I know you probably did that way back when. So you could do 4 times x, but typically we would just say 4x. And no, we don't even have to put an operation in there. Okay, all of those mean the same thing, but don't use x for multiplication. Okay, for division, if a equals b, then a divided by 8 equals b divided by 8. As long as I divide them both by the same number, then I'm okay. Okay, so those are just our 4 operations. They're all essentially saying the same thing, just a different operation going on. Okay, substitution, when we talk substitution, it's just like it sounds, right? We're going to substitute or take something and replace it with another. Something is getting substituted in. So if I said if x equals 3 and, thank you. So what's going to happen here, because x equals 3, then I'm going to take 3, I'm going to put it in for x, I'm going to substitute it in, right? 2 times 3 plus 4 equals 10. So the x gets replaced with a 3 because those two things are interchangeable. Wherever the x is, I can put in a 3. Those two things are exactly the same thing. Hey, and then the distributive property. This is one we've seen a lot before, okay? And where we typically will do the distributive property, I'm going to take this 4 and I'm going to distribute it. Okay, I'm going to multiply it throughout the parentheses. And so this would become 4x plus 12. We've done that already some this year when we've had a parenthesis and we've distributed it. And so I know that we know the distributive property, but today we're going to identify it. Okay, and we're just going to look. And so what's going to happen on a lot of these problems today is you're going to have to identify which of these properties is being used. I'm going to add one more property down here because I think we're going to see it at some point in time today. We call it the symmetric property. And I'm just going to give you an example of it. If x equals 3, then 3 equals x. When you solve an equation, what we've always talked about is it doesn't matter where the x ends up at, right? If you say 3 equals x and I say 3 equals x, or x equals 3, then those two are the same thing, okay? It doesn't matter where the x is at. The x doesn't necessarily have to end up on the left or the right. Those mean the same thing. And so sometimes when we solve an equation, there's more than one way that we can go about it. Typically, we like the x ended up on the left, but it doesn't have to be that way. And those two are still the same statement. So we call that symmetric because if something is symmetrical, that means I can flip it over, right? Here I can flip it over the equal sign, and it's still the same thing. Kind of like our bodies are symmetrical. We got eyes on both sides, arms, ears. We are symmetrical if we were get to split right down the middle, right? So we call that the symmetric property. Okay, ready for our first proof ever? Yeah, let's do it, huh? Okay. Almost every proof, not every single proof, but almost every proof starts with a given statement. We have to have something that we start with or are given, okay? And for today, that given statement is going to be the equation that we are given, right? This is the equation that the problem is stating, and so that is going to be our first step. So the first step, we're going to write out 3x plus 2 equals 37 minus 4x. Okay, eventually what we're going to do is we're going to get rid of this middle column. We're going to get rid of the explanation column. And we're just going to have a statement and a reasoning. But for right now, I want you to get used to saying what's happening here. Well, on this first step, it's pretty straightforward. This is the given statement. It is the statement that was provided or given to us at the beginning of the problem. And so, really simply, we just write given. Okay, we have to have something that we're starting with, and that today is going to be that given statement. Okay, from here, we're going to solve the equation. Okay, we're going to solve the equation like you've always done. And here's what I'm going to tell you. When you get to big ideas today, they're going to have like blanks, and you got to fill in the blanks as you go down. Okay, and it's going to be like a drop screen, I think, in most cases, where you got to drop something in. Okay, here we're going to talk about what we're doing. So typically when we solve for x, what would be the first step that I would maybe want to do here? Get the x on one side. Yep. We don't have any terms to combine, right? Because over here you can't combine these two. Over here you can't combine these two. So if I had something on the same side I could combine, I would. But now my goal is to get my x's to one side and my numbers to the other. Okay? So what side would be better to move the x's to? 4x to the left. Okay? And what would we have to do to move that 4x to the left? We'd have to add it. Okay? And for today, I think it's going to be good for you to write what you're doing down, because it's going to make a whole lot more sense. Eventually, you might be able to do it without writing that step down. But here, in the first time that we're doing it, we want to do this. Because here's what they're going to do. 7x plus 2 equals 37. So they're not going to show this. They're just going to say, what did I do to get from here to here? But if we write it down, we can see what we're doing, right? So what would we say? What would be our explanation? What did we do to both sides? We added 4x, okay? And that's all you're asking for here is what did we do to get from step 1 to step 2? And in this case, we added 4x. So if you see what's going on there, then that's a really easy explanation, right? Now here, for the reasoning is going to be a property, usually. So it's going to typically be one of the properties that we had up above. I know this is not a property, but we had to have a starting point. So if I added 4x to both sides of the equal sign, which property are we using? Not quite, because symmetrical just means the two sides are exactly the same. We would just flip them. It just, yeah, because, and once again, that's where this comes in helpful, right? Because I wrote adding 4x, well, what we did was we added 4x to both sides. So this is the addition property of equality. And I like to do a lot of abbreviating. We've talked about that before. Trying to make it as easy as possible. If you want to write out addition property of equality and do all that, go for it. But I like to do a lot of abbreviating. Addition property, and then instead of writing out the word equality, I just put equals in parentheses. Okay, and that's important because that's what keeps it equal. Okay, so we got to have that as equality. Okay, so that's our second step. We still don't have x by itself, right? That's our goal, is to get down to the point where x is all by itself. So what would we do next to solve this equation for x? Subtract 2. So step 3, we're going to write it out as 7x equals 35. And then what we can say is to get from here to here, we subtracted 2. And once again, by writing this out, we're pretty much telling ourselves what's going on here, right? So all we did was subtract 2. That's our explanation. And that's what I told you. Eventually, we're going to get rid of this middle column. But for this first couple of times, I think it helps to kind of show you exactly what's going on. And because we subtracted, then this would be the subtraction property. I don't need to put parentheses around that. Subtraction property of equality. Okay, I go ahead and write out the word subtraction, because if you just said SUB, that can be a little bit tricky because we have the substitution property and we have the subtraction property. So I don't just want you to abbreviate that one SUB. So you could probably go SUBT and abbreviate it that way. That would probably be okay. But I just go ahead and write out subtraction. Okay. Our goal when solving an equation is always to get x by itself, right? Have we gotten x by itself yet? No, we're almost there. So we got one more step to get there. What are we going to do? Divide by 7. So we get x equals 5. And we're going to say that we divided by 7. So this would be the division property of equality. Not all proofs are going to be 4 steps. Sometimes they'll be 3 steps. Sometimes that might be 5 steps. So they're not always going to be 4, but we label it 1, 2, 3, 4 just so we can identify the steps a little bit easier. So is this anything we've never done before? We've solved equations, right? All we're doing here is doing the y. And that's kind of what geometry is all about, right? Geometry, like on our quiz yesterday, was about proving why are those two things congruent, or why are they not congruent? Tell me a little bit more information. And that's what's happening here. Tell me why we can do each one of the steps that we are doing. Okay, one more time, we're going to have an explanation column in here, and then this will be the last time we have this in here, okay? You can always do this column, but just to shorten the proof down and have less writing, we won't always put this explanation column in here, just kind of to help us get started. Okay, so step 1. We're just rewriting the equation that we are given. So here, this is our given statement. And the reason why is because that's what we were provided. That's what we're given. And for these equation ones today, that's going to be your first step almost every single time. Okay? Eventually, that first step is going to change. Hey, as I solve this equation out, and that's really the question you're going to ask yourself. As I solve this equation out, what is going to be the first step to get w by itself? We're going to distribute, right? Okay, so we're going to take the negative 5. And my explanation is that we're going to distribute the negative 5 to the parentheses. And because we distributed, then, pretty straightforward here, that is the distributive property. Okay? A lot of these we don't have to overthink it. We just have to ask ourselves what we're doing. Okay, now we're trying to get w by itself. What would be our next step? Add 40, okay? Now, I'm going to tell you this right now. Most of the time, they're not going to show the work that's being done, okay? We have to understand, what did we do to get from here to here? We have to be able to identify that. That's why I like to write this in here, because then I think we have a better idea of what's going on. Most of you probably can do that without writing the plus 40 in there. But that's really my explanation. right here, adding 40. And so that would be the addition property of equality. Hey, how do we know when we're done? Because the W is by itself, right? So is W by itself yet? Nope. So we're not done yet. So step 4, I'm going to say W equals -2. What did we do to get to that statement? We divided, right? We divided by -35. And so because we divided, then that pretty easily tells me over here, then this is the division property of equality. And now we know we're done because we have W by itself and we have identified our reasoning for each step. Okay, so this next one here, notice that we have now gotten rid of the middle column, okay? That's what I told you. Eventually, we're still going to say it, we're still going to do it, but we're not necessarily going to write it out, okay? So it's just being able to shorten the problem down a little bit, not have to do so much writing. We just did it the first couple times so we can kind of get the hang of what that middle column was for. All right, number 1, step 1, rewrite the equation. And we're just going to write given. Here's the equation we're given, and that's why we write it out. Sometimes these steps can maybe be rearranged. They may not always have to be in the same order. You might look at somebody else's and they may not have done things just a little bit differently. But in this one, the next step, my second step, has to be what? Distribute. Anytime we see parentheses, just think order of operations. Parentheses has to be first. And what are we going to do to get rid of the parentheses here? Distribute, okay? So all of those are good words because those are things that tell us what we're doing each time. So to get from step 1 to step 2, we took the 6 and we distributed it. We don't necessarily have to say what we distributed. That's what we did in the explanation column, okay? We're just saying we use the distributed property. Okay, for step 3, we haven't seen this one yet. Okay, as I solve this one, what would be our next step? Okay, good. Yeah, we have B's on the same side as one another, right? We got to put those together. Okay, and a lot of you guys said add like terms. What we have probably said before is combine like terms. As long as they have the same variable or the number. Sometimes we'll also see this. We're just simplifying it, okay? We're trying to combine things together that are alike. So the word simplify is another one that we could use. And it's a little bit simpler, but combine like terms is a little bit more informative, I think. Okay, trying to get B by itself. We're not there yet, so what do we got to do next? Subtract 12. Good. Okay, and you don't necessarily have to show that you're subtracting 12, but once again, I think it does help. So that when you do this step right here, you can say that that is the subtraction property of equality. We're almost there, right? Still don't have B by itself, but we're really, really close. And so I got to get rid of the negative 16. And so to get rid of the negative 16, we would divide by negative 16. What happens when I take negative 8 divided by negative 16? Becomes a positive. Okay, what else? It does equal a fraction. Okay, and what can we do with 8 over 16? Half. Yeah, reduce it, right? So it is a positive, and we reduce the fraction, so it would be 1/2 equals b. Okay, I'm going to show you one thing here. So what we did here was division, property of equality. Okay, if I write, and sometimes big ideas will do this, and you're going to see this from time to time. If I rewrite it like that, what property, what did I do here? 1/2 equals b became b equals 1/2.
It's the last one.
Yep.
It's
Symmetric.
symmetric.
Yeah, symmetric. Good. Okay. And the only reason they do it that way is so that the variable ends up on the left. Okay. And a lot of times that's where we want the variable to end up. It might just say prove that b equals 1/2. So that's the statement that we want. Even though 1/2 equals b is essentially the same thing, we want to get it to where b equals 1/2. Okay? All right. Any questions on that one? All right, here's what I'm going to do. The bottom one first, and then we'll come back to the top one because I think the bottom one's just a little bit easier. Okay. So this one's going to be a little bit more difficult because we're going to have like a formula of some kind. Maybe a formula we've seen before, maybe not. Okay. And we are going to solve it for a specific variable. And so in this case, the formula is 1/2 base times height. Anybody remember what that is the formula for? Triangle. Okay, we saw that in chapter 1. Area of a triangle is 1/2 base times height. Adrian, let's take your cap off. Okay, so this is going to be the same thing, but it says that we're solving it for b. Okay, so when it says solve for b, that is the variable that we're getting by itself. So when I'm done, I'm going to have something that says b equals whatever. Okay? What could we do to get rid of the 1/2? Multiply by 2. Okay? So here's what I'm going to do. I'm going to say multiply by 2. So on the left-hand side, I'm going to have 2a. And the reason we choose to multiply by 2 is because it's the reciprocal of 1/2. 1 over 2 becomes 2 over 1. And when I take 2 times 1/2, what happens? Turns into 1, right? And so we don't necessarily need to write that 1 right there because we know that's assumed to be 1bh, but we're just going to write it as bh. Okay, what property do you think we would put here? Multiplication. Good, because that's what we did, right? We multiplied by 2 on both sides, so that's the multiplication property of equality. Okay, for step 3, we're trying to get b by itself. What's happening with b and h? What up? They're multiplying, right? So to get rid of the h, we're going to divide. Okay, and I know I've said it a lot already, but if it helps you to show you what we did, then write it in there. Just put like divide by h, like I did with the times 2. So now we have 2a over h equals b. and we did the division property of equality. Okay, have we solved for B? Okay, so that's it. Okay, in some cases, it may take it one step further and it may put the B onto the left. I'm just telling you that, and that would be symmetric property once again. But if it was on like a quiz or a test and you stopped right here, I'm totally okay with that, okay? Unless it says to finish with B on the left or something like that. All right, the one up here is a little bit more difficult, I think. And there's two parts to this one. And you're going to have one like this on Big Ideas today. So that's another reason why we're going to do this one. Hey, there's a couple of different ways that this could be done. But first up, we're going to take the formula that we're given. First step should be the easiest step today. It's not going to change. Just taking the formula that we're given or the equation that we're given. Okay. It says P is your previous wage. R is the percent increase written as a decimal. N is your new wage. Solve the formula for R. So we got to read through all of that, get out of it what we need. Hey, now here is an example that I would show you. I don't really want to distribute the P because that's going to make this much more difficult because we got a lot of variables going on in here. We have a P, we have an R, and we have an N. Okay? And so to make this one a lot more simpler, then I would get rid of the P first. Okay? You could distribute the P, but it's going to make the problem a little bit more difficult. So let's get rid of the P first. And what are we going to do to get rid of the P? Divide it. Okay? Rather than distributing it, we're going to divide it. And we're going to do it on both sides. So this gives me R plus 1, because the P's are going to knock out, equals N over P. Our goal is to solve for R. So we want to get R by itself. So what are we going to do next? Minus 1. Okay, I forgot to write the property over here. So on the first step, we did division. We divided by P. On the third step, we subtracted 1. So that would be the subtraction property of equality. Okay. But we're not done, okay? Because here's the reason why we would do something like this. You might say, what in the world would be the purpose of getting R by itself? I can take this formula, I can solve it for R, and now, if I look back up here, P is the previous wage, N is the new wage, and R is your rate. We don't know the rate, okay? But if I wanted to figure out what kind of increase did this person get at their job, their hourly rate went from $7.25 to $7.54 an hour. What would be the increase percentage-wise? So here's what we're going to have to do. The new rate is $7.54. The old rate, or previous rate, is $7.25. Minus 1. So let's take 754 divided by 725 and then subtract 1. What do we get? 0.04. Okay. And so what that means is this person got a 4% raise. Why would a job or a company offer a 4% raise to their employees rather than just saying, I'm going to give you 50 cents more an hour? Why would they do a 4% raise rather than a 50-cent raise? Anybody have any idea? What if I'm making $7 an hour and somebody else has been there for a long time and they're making $15 an hour? Is it fair for me to get a 50-cent raise and them to get a 50-cent raise? No. So if I do a percentage raise, then we would both get an equal raise, but it wouldn't be the same in a dollar amount or a percentage or a cent amount. Okay? So that's why you would do a percentage raise. So most of the time if you get a raise, your company will offer you a 3% raise or a 4% raise. It's not going to necessarily just be an increase in the hourly rate. Okay, we have big ideas up today. 2-4 day one. Tomorrow we have some more with 2-4. And then we got another big ideas tomorrow too. Might make more sense to see it with some numbers in here. If I said 2 times x plus 1 equals 12. Do we have to distribute the 2 first if we're solving for x? Typically, we would say yes, okay? I'm going to show you 2 ways that we could do this. Most of the time, that's what we would do, okay? I would distribute, I would subtract 2, and I would divide by 2. And I get x equals 5. But I'm going to show you what else we could do. So on this one, since we're trying to get x by itself, and there's nothing else connected over here, then I'm taking 2 times this whole thing, right? So what else could I do to get rid of the 2 here? Divide. As long as I'm doing it to both sides, it's okay. And then I can subtract 5 and look what happens. So does it matter which one I do? No, okay? If you had to look at these 2, which one is a little bit easier or which one took a little bit more time? The second one I think is a little bit easier, right? This one took a few more steps. This is the way most of us probably would have gone, right? And that's okay. It's not wrong. This is a little bit easier. Now, I show you this because on this one over here,